starting our first option unit today. Yeah, we're starting quantum mechanics. Okay, it's a little tricky, obviously. It's quantum mechanics. But the curriculum that IB puts forward kind of focuses on some of the early concepts, so it's not going to be too math heavy. I'm not going to have to teach you, differential or integral calculus or anything like that. The curriculum focuses on some of the concepts and the high school level mathematics. That's easily understandable. That being said, okay, so as I was developing this, how I wanted to start, okay, the curriculum starts about 10 years into quantum mechanics. But I wanted to give you the transition from where we left off, which is the black body spectrum. Because that black body spectrum is the key transition from where classical physics broke down. And all of a sudden people were trying to fit theoretical curves into something that really defined what should have happened. I'm going to explain that a little bit more in a second. Anyway, just to give you a little teaser where we're getting to, though. Quantum mechanics has implications that go everywhere from philosophy to consciousness to religion. There's debates that scientists in all pathways, in all disciplines, try and incorporate the concepts of quantum mechanics, sometimes falsely, sometimes kind of obscurely, but it's really neat. So some of the things that quantum mechanics suggests is that every single object that has mass has an associated wavelength to it. Okay, there's an uncertainty in every object's location based on its wavelength. Okay, we're all vibrating at a certain super high frequency. Now, there haven't been applications of quantum mechanics in the macroscopic world. Okay, we haven't been able to duplicate humans and separate them into different probability distributions, but we're getting there. Another thing that quantum mechanics kind of hints at is that the scientific process at the small scale of things is invalid. Okay, there's no possible repetition of results when you're dealing with quantum mechanical effects, because things don't exist in one specific location at the very small scale, the scale of photons and electrons. Okay, so the scientific process itself is negated. So modern physicists have to develop entirely paradigms of the scientific process. It's kind of weird.
So how do you kind of make it useful then?
How do you make it useful? It's the applications of quantum mechanics that we use, not even necessarily even if we don't know why they happen, and a lot of things we don't know even now. Adam?
Well,
it can be. There's not really. No. Things are still going to fall to Earth. You're not going to ever fall through the floor. You're not going to be able to walk through walls or anything.
Like those questions they gave us about like centrifugal force around an atom. That's not true, right?
Not quite. No. Yeah, that's a simplification. That's a model. That's no simplification. Also, just another two more neat things about quantum mechanics before we even start the history is that it also broke the laws of relativity. And the laws of relativity said that nothing can travel faster than the speed of light. Well, all of a sudden, when two particles are created from the same mass, those two particles are connected, instantaneously connected. When one changes spin, the other one changes spin immediately, regardless of the speed of light.
Really?
Yeah.
So something can actually possibly happen immediately.
That's one of the biggest questions that no one has even a theoretical model as to how those two things are connected instantaneously. It's crazy. That's Einstein discovered it. It was called the Bose-Einstein condensate, and he called it spooky action at a distance. Close.
That's awesome.
Yeah. Rob? That's quantum entanglement. Yeah. And lastly, there's also a thought that the universe can only exist because of conscious observers in the universe. Consciousness may be a requirement of a universe. not just interactions of matter, but consciousness may be a requirement for the universe. It's kind of like the chicken or the egg debate, which came first. Well, obviously the universe came first, but perhaps the universe only exists because there are conscious beings to observe the universe. Really strange stuff. Quantum mechanics, it's interesting. Okay. I want to show you a video of quantum physics, famous quotes from
Talk about that over there.
No, oh, that's one of them. Yeah, at the turn of the century, Lord Kelvin said that we're done with physics. That's it. We've figured out everything. That's it. We know how everything works. We know how planets rotate. We know how atoms work. We know the structure of atoms, and then that black body spectrum destroyed everything. What's that? No, I don't think so. So this is kind of a silly little video. The guy did,
Look, quantum physics is confusing and surprising enough to me. But don't take my word for it. What follows is a series of quotes from the very men who developed quantum physics and the luminaries who continue to advance it today. Good luck. This is not for the faint of heart. For those who were not shocked when they first come across quantum theory, they cannot possibly have understood it.
God does not play dice with the universe. I don't get what to do.
If that turns out to be true, I'll quit physics. When you change the way you look at things, the things you look at change. Very interesting theory. Makes no sense at all.
The paradox is only a conflict between reality and what you think reality ought to be. I like to think.
I'm gonna do a different one. Huh?
A philosopher once said
I want side
that it is necessary
and see
for the very
for the really
existence of science.
a working of side. I don't know a good one.
It's a tricky one. That the same conditions always produce
All I could do.
the same results.
okay, this is the breakdown of the scientific method.
Well,
Well,
they don't.
then don't.
As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality.
It is wrong to think that the task of physics is to say how nature is. Physics concerns what we can say about nature.
Nothing happens until something.
The doctrine that the world is made up of objects whose existence is independent of human consciousness turns out to be in conflict with quantum mechanics and results and facts established by experiment.
In the beginning, there were only probabilities. The universe could only come into existence if someone observed it. It does not matter that observers turned up several billion years later. The universe exists because we are aware of it.
So stand over here, and I'll tell you the lines. Ready? It starts with, I like to think
I like to think
that the moon
that the moon
is there,
that the moon is there
even when
even when
I'm not looking at it.
I'm not looking at it.
Very good.
I think I can safely say that no one fully understands quantum mechanics.
Richard Feynman was one of the leaders in the realm of quantum mechanics, and he said, I think it's safe to say that no one understands quantum physics.